All right. Hey guys, it's Mr. Oda. This is going to be our first video lesson for Unit 4, which is Earth Systems and Resources. Now, if you're a student who's coming with a background in Earth science, the topics in this unit will be very familiar to you, and we're going to discuss them in a second. But first, what we want to do is make sure we know what we're trying to learn here and what questions we're trying to answer with these topics. So for this unit, you have a couple different essential questions. The first one is, how did the current continents form? And what influence has geology had on the life on Earth over geologic time? So the first thing we're going to talk about is how the continents didn't always look the way they do now. The second question is going to be, how does the atmosphere influence life on Earth? The third question, what determines seasonal changes in different parts of the world? So, for example, why is it winter time now in January for us, but in other parts of the world, it's actually summertime, much warmer? And for the fourth question, what geographical factors determine an area's climate, weather, and life forms? We're going to be looking at all of that and more in this unit. And overall for this unit, the overall understanding you want to have is that all of Earth's systems interact, resulting in a state of balance over time. The Earth is very good at keeping things balanced in every way, whether we're talking about food chains and food webs, or if we're talking about the state of the atmosphere. We're going to talk about all of that in this unit, starting with topic 4.1. Now, this is going to be for topic 4.1, plate tectonics. Again, if you are a student who's had experience with earth science, you may have heard of this before. If you have not, we're going to be going over this together. And so your learning objective is going to be to describe the geological changes and events that occur at convergent, divergent, and transform plate boundaries. We're going to define those together. And for your skill, you're going to want to explain how environmental concepts are represented visually and relate to broader environmental issues. We're going to be seeing a lot of different things that happen around the world, and what you're going to be doing is explaining how those affect people and the environment. Now, as many of you guys have probably heard before, way back millions of years ago, the Earth did not look the way it does. There was a thing called Pangea, which was known as the supercontinent. And what it was is all the land masses combined together as one. Now, currently, we think that the continents have moved over millions of years to look the way they do now. Now, the question is, do you know why this has happened? To find the answer for that, we're going to be looking at the layers of the Earth and how the Earth works. So, the layers of the Earth are as follows. Where we are right now is the lithosphere, or as it's more commonly known, the crust. That is the land, the sea, and everything there that you see right now. Underneath that, we have what we call the mantle, and it's split up into the asthenosphere, which is the upper mantle, and the mesosphere, which is the lower mantle. Okay? And the idea is that all the land and sea that we're on, we're actually floating on top of what we call plates. Now, these plates are floating on the more dense lower portion, which means that the lithosphere, let me redo that. To figure this out, what we're going to do is we're going to look at the layers of the Earth. Now, The layers of the Earth as follows. We first have what we are standing on right now, which is the lithosphere, or it's more commonly known, the crust. This is the land, the sea, everything that is on top of the outer layer of the Earth. And the other layers, starting to go below that, are the asthenosphere and the mesosphere, which are all part of the mantle. And if you notice on the picture, it's an orange reddish color. And that's because underneath the land and the sea is a lot of molten rock and magma. And so what you have here is that the land and sea are on top of what we call plates. And they're less dense, they're the least dense part of the crust, and they're actually floating on top of that molten rock. They float on top of the asthenosphere. And because they're floating, they're able to move in various directions. The reason why they move is because of convection currents. We're going to learn more about this as the unit goes on, but what you'll see is heat rises, and as it cools down, it goes lower. And so what you're going to see underneath the surface of the Earth, underneath the lithosphere, is just molten rock, the asthenosphere, moving in circles, bringing the land and the sea with it on those plates. These plates can move in different ways, and what they're going to do is create various different events and hot spots. So this picture gives a nice brief overview of the types of plates we're going to see and the ways that they can interact at their boundaries or where they interconnect. One thing to keep in mind with all of this, especially for when we go to our first type of plate boundary, is that there's a difference between oceanic and continental plates. Oceanic plates are ones that hold mostly ocean on top of them, where continental crust holds mostly the land. And one key thing to remember is that oceanic crust is younger and it is more dense than continental crust. It is more dense, and that is going to be what we need to remember. Now, our first type of plate boundary is called a convergent plate boundary, and this is where two different plates move towards each other. Now, when it's two different types of crust, what's going to happen is that the more dense plate is going to actually be pushed down because of the force. This is called a subduction zone. As it goes underneath, sorry, as it goes underneath the other crust, it's going to melt because the center of the Earth is much warmer, and it's going to create magma. What this is going to result in is a volcano forming because of the rising land and the molten rock below. It will create a volcano. What it can also do is create trenches, which are just seafloor droppings, as well as earthquakes. These land masses colliding would cause a lot of friction and a lot of force that will cause a large um, earthquake to occur. Now, when you have convergent plate boundary with two oceanic plates, this will be somewhere in the middle of the ocean. And what you're going to see is it will also create volcanoes. But once the lava cools, it will turn into new land, forming island arcs. So once the volcano erupts, the the magma will cool off, the lava and magma will cool off, turn into rock, turn into new land, and then you'll get islands in the middle of the ocean. One very popular example of this is Japan. Japan is a country that is all islands, and they are formed because of the plate boundaries there pushing against each other, creating volcanic activity. There are many famous volcanoes around Japan. They're still active to this day. Additionally, you can also have convergent plate boundaries when there's two continental plates. So that just means that two pieces of land are pushing against each other slowly. And what this is going to do is it's going to create mountains. The crust will move against each other, folding up and rise up to create mountains. And there are many different examples of this, but the most famous one is the Himalayan mountains in the border between India and China. And for reference, this would be the collision between the Eurasian plate and the Indian plate, which will give you the Himalayan mountains. And one of the mountains there is Mount Everest, which is the largest mountain currently, and it is still growing to this day. Now, the opposite of convergent plate boundaries would be divergent plate boundaries. This is going to be where the plates push away from each other. And what this is going to result in is the seafloor spreading. There's going to be a massive gap in the crust where the seafloor is going to get a lot deeper. This will create rift valleys. This could also create volcanoes because the seafloor opening up will release magma from underneath the ground. And again, this can also create some earthquakes, although not as much. And the best example, the image that's on screen right here, is the Mid-Atlantic Ridge, which is a very famous tourist spot to go to, or at least for divers who are looking for adventure. And one last thing to note is that this will create new crust because, again, the magma will flow up, cool, and create new crust or new land. And finally, the last type of boundary is transform boundaries. This is where the plates are not moving towards or away from each other, but they're actually sliding next to each other. And this is not going to cause anything other than earthquakes. This is actually going to cause earthquakes to happen very frequently. What happens with this is that the two plates will lock together as they're sliding up against each other. And this is going to build up some stress, some energy, some pressure. So the pressure is building up, building up, building up as they're trying to slide past each other. And then when they actually do release and slide, all of that built up energy is going to release, which can cause an earthquake. The longer that these plates are stuck together, the more energy that builds up and the more devastating the earthquake will be. Now, this actually hits close to home for us because there's actually an example of this in America, and that is the San Andreas fault line. San Andreas and the state of California are on a fault line where there's two plates that create a transform boundary. They're sliding up and down next to each other. And every so often, San Andreas and the area around there is hit by an earthquake. One thing they're very worried about right now in the year 2021 is that they have not had an earthquake for a very, very long time. And so what that means is that energy has been building up for many years. And they're worried that the next earthquake will be incredibly devastating. Now, just to check for your understanding, in your own words, summarize the differences between transform, divergent, and convergent plate boundaries. I hope you're paying attention. And remember, the difference between these all has to do with how they're interacting and which direction they are moving. And since this is very relevant to us again, explain the tectonic plate activity on the west coast of the United States. So what what is happening at the San Andreas Fault? Make sure when you explain that, you mention what type of boundary it is. Now, to round this all off, what you see at all these plate boundaries is a lot of different natural occurrences, natural disasters, if you will. And one place in the world where this happens frequently is known as the Ring of Fire. This is the area in the Pacific Ocean all from the edges of South America and North America to Asia and even Australia. What this is where many different plates are colliding, moving against each other, moving apart, and you're going to see a lot of different things happening. All these triangles are different hotspots and events, most likely volcanoes. You'll see there are a lot of them near Japan. And there's a lot of activity over here in North America by, again, San Andreas. Additionally, what you'll see with this kind of interaction is that some of these plate boundaries can cause what we know as tsunamis. They're caused by underwater earthquakes. This can cause many different ecological consequences. So when you have the earthquake underground, it creates a big upward wave, which could damage habitats, drown species, uproot trees, contaminate water, and it can also cause massive damage to human cities. Again, this is an image taken from Japan, as they are very close to many fault lines. They have frequent earthquakes underground, which will result in tsunamis, which can cause many problems for the animals, plants, and the humans that live there. This is, again, an image of the world, but showing you the plate boundaries and how they are moving. So we have Convergent over here, they are moving together. Divergent, the Australian plate and the Antarctic plate. You may want to refer to this every so often to remember which way the plates are moving. Now, to check for your understanding, take a look at this image. Look at the way that they are moving. What type of plate boundary is shown here? Hope you were able to get that. Second question, at a convergent boundary, hotspots may form because one plate falls below another. This is called what? The image pretty much shows it, but doesn't give the answer exactly. You should remember that when one plate falls under the other, we call that a subduction zone. Another question for you guys. You can always refer back to the images from before. Which location on this map would show island arcs? Where would you see island arcs being formed? Hopefully you were able to remember that we talked about Japan as an island arc. So that would be line E. The next question, which location exhibits a growing mountain chain? For this one, you want to remember that we talked about the Himalayan mountains over near India, which would be on line C. And finally, in which area is new crust being made because of a divergent plate boundary? And now for this one, hopefully you remember the mid-Atlantic ridge. So in the middle of the ocean, the seafloor is going to be opening up, creating new crust. And so that would be answer B. Okay. I know that was a lot of information on plate boundaries. If you have any questions, please ask them in class. And I will see you soon. Okay. I know that was a lot of information about plate boundaries. I hope you guys got a lot of information from this, and I hope you guys feel more confident in this topic. If you have questions, you can ask them in class, and I will see you in the next video.